I'm Rob Higurita, and I'm an enterprise support lead at AWS, and I'm based out of Austin, Texas. Welcome to AWS Supports You, where we share best practices and troubleshooting tips from AWS support. Joining me today is Tom and Sabrina from AWS Customer Optimizations and Clint from AWS Support. Can you give us a quick introduction, Tom, Sabrina, and then Clint?
Sure. Thanks, Rob. Hey, I'm Tom, an optimization specialist based out of Chicago, and I help customers manage their cloud costs by leveraging features and tools available in the AWS console. It's great to be here on the show today. Thank you for having me.
And hi, everyone. My name is Sabrina. I'm also an optimization specialist based out of Detroit, Michigan. And I help educate customers on best practices for monitoring and optimizing spend on AWS. Happy to be here.
Hey everyone, my name is Clint Wyckoff and I'm an enterprise support lead and technical account manager based in Pittsburgh, Pennsylvania. So I help lead a team of TAMs here, as well as support my own customers in their journey to the cloud and help make that as successful as possible. It's good to be here.
Thanks everyone for the intros today. And today we'll be introducing everyone to the AWS cost optimization, and we'll specifically focus on the best practices for optimizing storage and compute costs. But before we get into the details today, a quick note to the attendees online. Please feel free to take advantage of the chat window on the right-hand side of your screen to share your thoughts and ask your questions throughout today's episode. We really look forward to hearing from you and interacting today. Tom, can you go ahead and walk us through what we're going to be talking about today?
Sure. So today we'll start with storage and the importance of choosing the right type of storage for your workload based on access requirements. Then we'll review how to enforce retention periods for stored data using lifecycle rules. From there, we'll cover several optimization principles, which include modernizing technology, right-sizing infrastructure, and architecting for elasticity. We'll conclude with an overview of the AWS pricing models and how they can be used to lower costs. First, by reserving capacity through commitments, known as savings plans or reserved instances, and then by utilizing spare compute capacity in the AWS cloud for fault-tolerant workloads. For those of you that joined us last week, we covered the C phase of the AWS Cloud Financial Management portfolio and how to establish centralized cost visibility for your environment. If you didn't have a chance to attend, we encourage you to view the recording available on YouTube. Now, with that transparency, we can move to the save stage and explore savings opportunities. Note that this time next week, we will be covering the plan and run stages, so be sure to tune into those sessions as well. So the first savings opportunity we want to cover today is the storage classes for Amazon's Simple Storage Service, commonly referred to as S3. There are 6 storage classes that differ in pricing and behavior, so it is important to choose the right one for your data based on use case and performance requirements. Starting with S3 Standard, although this class costs the most per gigabyte, it is the most cost-effective storage class for frequently accessed data because it does not charge a data retrieval fee. Compare that to S3 Standard Infrequent Access or Standard IA. This class is almost half the price of Standard in terms of per gigabyte storage, but it does have data retrieval fees. It also has a minimum storage duration of 30 days, meaning if an object is transitioned to a different storage class before 30 days pass, you will still be charged the full 30 days. That said, Standard IA is ideal for data that is not accessed frequently, but requires rapid access when needed. The next class, S3 One Zone IA, is similar to Standard IA, except data is stored in a single availability zone and is not resilient in the event that AZ were to be destroyed. Because of the reduced resiliency, One Zone IA is 20% cheaper than Standard IA. S3 Glacier is a storage class that is 83% cheaper than Standard, but also has a standard latency of several hours when retrieving data, although this can be expedited by paying a premium. Because it also has a minimum storage duration of 90 days, S3 Glacier is suitable for data archiving and backups that likely won't be accessed. And even colder storage is S3 Glacier Deep Archive, which offers the lowest cost per gigabyte storage on AWS at 96% the cost of Standard. However, it does have the highest latency with a data retrieval time of up to 12 hours that cannot be expedited. It is designed for the long-term retention of data that will be retained for 7 to 10 years. The last storage class is S3 Intelligent Tiering, which is designed to optimize costs and reduce operational overhead by automatically transitioning objects between storage classes based on when they were last accessed. As an example, when an object is first created with intelligent tiering, it starts as standard. But if the object hasn't been accessed in 30 days, intelligent tiering will automatically move the object to standard IA. Then, if the object is accessed, intelligent tiering will move the object back to standard and the transition timer will reset. Something important to highlight is that intelligent tiering has no retrieval fees, minimum storage durations, or minimum billable object sizes, and AWS recently announced the removal of the monitoring fee for objects smaller than 128 kilobytes. Additionally, you can opt into S3 Glacier and S3 Glacier Deep Archive classes as well. For these reasons, intelligent tiering is ideal for objects with unknown, changing, or unpredictable access patterns, regardless of size or lifespan. Now, I want to provide a similar overview for EBS volume types, which are the block storage attached to EC2 compute instances. EBS volumes fall under two categories, your solid-state drives and your hard disk drives. Starting first with our general purpose SSDs, this is GP2 and GP3. GP2 is the default volume type when creating most instances, as this volume type provides a balance of price and performance. However, GP3 volumes offer 20% cheaper storage and 4 times the amount of throughput compared to GP2, which can lead to cost savings. Now, with our provision IOPS SSDs, IO1 and IO2, these volume types provide the highest performance, but in return cost 25% more than GP2. IO2 volumes also support Block Express, which delivers SAN-level capabilities in the cloud for the first time. Moving over to our hard disk drives and our throughput optimized ST1, this volume type is ideal for streaming workloads because it offers the lowest cost per amount of baseline throughput delivered at 55% the cost of GP2. And the last volume type is our cold hard disk SC1, which is ideal for infrequently accessed data at 95% the cost of GP2. One thing that's important to note is make sure that any unattached EBS volumes are deleted to avoid paying for storage that is not being utilized. I'll show you how to do that in a moment during a demo. But first, Clint, for S3 and EBS, how can customers determine which type of storage is appropriate for their workload?
Yeah, Tom, thanks. And so earlier you had touched on the different storage tiers that are available within S3. And one of the features that has been around for quite a while now there is lifecycle policies, which does require users to have a good understanding of how frequently the objects that are stored within their S3 buckets are being accessed. So within that lifecycle policy, which we'll dive into deeper a little bit further, you can set up a policy that would tier the data based on the days and the retention that you specify. So intelligent tiering really aims to simplify that entire process. So you don't have to worry about utilizing S3 storage class analysis or monitoring the S3 objects within the storage metrics tab. So that's how you can view the frequency of the objects and when they're accessed. So intelligent tiering really aims to make that entire process a lot easier. And there's really two different access tiers there for frequent access, which is for the objects which are infrequently accessed. And then after 30 days, those objects are moved down tier. As you mentioned, you can optionally enable the archive tier, which means that after 90 days, they're going to be moved off. And then there's even further, so you can deep archive access that after 180 days. And this is something that we're seeing customers, especially within enterprise support, that our customers are taking advantage of there to cost optimize, right size their buckets and make sure that they're making the best use of the storage there within S3. On the other side of the coin, you have the GP volumes, and GP stands for general purpose. So these are our solid state block storage where you can actually run EC2 instances or RDS clusters, for example. And as you mentioned, Tom, GP2 is the previous generation. It still is the default. So for customers that are looking to get up to 20% cost savings, cutting over or changing your launch configurations or your AMIs to leverage the GP3 storage volume type is very common access. So the difference between GP2 and GP3 is, as I mentioned, it's less expensive, 8 cents per gig versus the 10 cents per gig with GP2. The other interesting tidbit there, Tom, is that you're actually able to decouple the performance away from the capacity. So that helps you save money. as well. So with GP3 volumes, you get a baseline performance of 3,000 IOPS and 125 megabytes worth of throughput. And they have the ability to, if you do pay a little bit more, whenever you provision that volume, you can scale up to 16,000 IOs as well as 1,000 megabytes per second. Whereas the GP2 volumes, they max out at 25 meg. And then the last topic that we'll cover here on the storage front is the provisioned IOPS and the introduction of the IO Block Express there, which went GA in July of this year. The interesting tidbit there is for customers to call out and realize as those are explicit to the R5B as in boy instance type. So these are definitely suited for mission critical applications that are storage intensive. And I think the number one takeaway for customers, at least the customers that I work with that are very intent on their storage and making sure that they're making best use of the different classes and options that we have there, is there's really storage profiles or types of storage that are available for virtually every single use case. But it's important to do performance testing whenever you're going out there to choose the right volume size, the right volume type. You don't want to overpay or undersize for performance. So using tools like FIO, for example, allows you to test performance and look at metrics within CloudWatch and things. So
great. Thanks a lot, Clint. That's a lot of great information. One thing that you touched on was lifecycle rules, and that's what we'll be covering here next. This is another best practice for optimizing storage. First, focusing on S3, there are two types of lifecycle rules that can be applied to objects using Amazon S3 lifecycle. The first is a transition rule, which will automatically transition objects to a lower storage class after a set number of days. And then there's also an expiration rule, which can be used to define when objects expire and therefore automatically deleted. For EBS, use Amazon Data Lifecycle Manager to automate the creation, retention, and deletion of EBS snapshots and EBS backed AMIs. This feature allows configurable parameters for volumes, snapshot frequency, and retention. So before moving on from storage, Rob, are there any questions from the audience regarding any of these topics?
Thanks, Tom. We do have one question from the audience here that came in from Rela Chahe. It's, can I stripe volumes together? I don't know if you have any intake on that one.
Yeah, you definitely can stripe volumes within the guest operating system as long as the operating system obviously supports that, but definitely that is something that you can do.
Great, thanks. Back over to you all for the rest of the presentation. Thanks.
Thanks, Rob. Okay, so a couple of cost optimization principles in accordance with the AWS well-architected framework are modernization, rightsizing, and elasticity. As a best practice, customers should develop an internal strategy to monitor for these principles to accelerate the value realization of the cloud. Modernization is the process of upgrading to current generation technology, as it is not only faster, but also cheaper. Rightsizing is the process of matching infrastructure with the performance and capacity requirements of its underlying workloads. And elasticity is the ability to acquire and release resources based on need. As cloud technology continues to evolve at a rapid rate, optimization is a continuous process that should be revisited on a regular basis. If you have any questions on these topics as we go through them, make sure to ask them in the chat and we'll be sure to address them. So starting with modernization, there are many modernization paths available, but we're just going to focus on two today. The first is the AWS Graviton2 processor, which for Amazon EC2 instances, these ARM-based processors deliver 7 times the performance at 20% the cost. Graviton2 processors are also available for Amazon RDS, Amazon Elasticache, Amazon OpenSearch Service, and AWS Lambda functions as well. The other modernization, as we touched on previously, was modernizing your EBS volumes from GP2 to GP3 and IO1 to IO2. GP3 volumes have 20% cheaper block storage, and as Clint mentioned, you can also scale IOPS and throughput independent of your storage capacity, unlike GP2. And with IO2 volumes, they offer 10 times more IOPS per gigabyte than IO1 and offer economies of scale for provision IOPS. Clint, how have customers that you support successfully migrated workloads from traditional Intel-based processors to Graviton processors?
Thanks, Tom. So what we're seeing customers that aren't leveraging third-party off-the-shelf application that they might have deployed inside of an instance. So this is something that might be a homegrown application or code that you natively control that you're able to go out and edit and change to be able to support the ARM-based processor type, which is what Graviton is based off of. So if you do have those third-party off-the-shelf applications, you'll definitely want to check with the support vendor there that you've purchased that off of to check and see if it does support Graviton. But what we're seeing customers do is dip their toe in the water and test out Graviton. And the way that they're doing that today is up until the end of the year, December 31st, 2021 this year, new and existing AWS customers can test out the T4G. So you have the instance family, which is the T family, the fourth generation, and G at the end of it stands for Graviton there. And they're able to test out the T4G micro for up to 750 hours per month. And that is for existing and new customers as well. And there's also Graviton-based processors for the the M6G, the T4G, C6G, which is compute, and R6G, which is memory intensive instance family there. And really we're seeing customers not only pay less as compared to what the Intel counterpart costs, but also be able to get better performance as well whenever they're running those same applications on the Graviton processor base. So I can explicitly think of one customer that I work with now today that's part of AWS enterprise support that is testing out some of their applications on Graviton. The other piece that I wanted to touch on here, Tom, which we sort of alluded to a little bit earlier, is the migration from GP2 over to GP3. And the reason why customers are doing that is from a cost perspective, but also from a performance perspective. So that modernization effort from a storage front, is something that they're taking advantage of. And the way that they're doing that is they're updating their AMIs, they're updating their launch configuration, they're updating their auto scaling groups to leverage the newer volume type. I will say that GP2 by default, if you go to launch an EC2 instance today, still is the default. So you need to go in and make some changes there. You can migrate over existing GP2 to GP3 volumes without any downtime. Just note that you can't resize or shrink down the volume. So if it was a terabyte volume on 2, it'll be a terabyte volume on 3 as well.
Great, thanks, Clint. So moving on to rightsizing, there are 2 tools that offer rightsizing recommendations, and both need to be enabled first. AWS Compute Optimizer detects over-provision and under-provision EC2 instances, EBS volumes, EC2 auto-scaling groups, which we'll get to in a moment, and AWS Lambda functioning. Over-provisioning causes unnecessary infrastructure costs, whereas under-provisioning may lead to poor application performance. Compare that with the rightsizing recommendations available in Cost Explorer. These provide a subset of the Compute Optimizer results that may lead to cost savings. And these recommendations are further augmented by accounting for usage covered by savings plans or reserved instances. The accuracy of the recommendations in both of these tools can be improved by enabling the Amazon CloudWatch agent to collect metrics on memory utilization for EC2 instances. Now, the last optimization principle is elasticity, and the 2 options are auto-scaling and scheduling. EC2 auto-scaling groups are a way to account for workloads with large demand spikes. A scaling plan can be configured to automatically add computing power to handle the load on your application and remove it when it's no longer required. With scheduling, use AWS Instance Scheduler, a CloudFormation solution for workloads that don't need to run 24/7 and can be stopped at certain times like nights or weekends. Customers can configure custom start and stop schedule for EC2 and RDS instances. Now, there are design considerations to make when implementing this solution, so be sure to review the documentation first. Rob, are there any questions that came through on these optimization principles?
Hi, Tom. No questions from the audience right now specifically on that, so I'll let you continue here into your next section.
Hey, Tom, you're muted there, bud.
Oh, sorry about that. Clint, I was going to ask you, when can customers realize cost savings from using auto scaling?
Yeah, so auto scaling groups, as you mentioned there earlier, you touched on it pretty quickly, that no longer are customers or users required to over provision to handle all of the capacity load like they would to inside of an on-prem data center today. So you have to be able to be able to leverage an auto scaling group to automatically scale out based on CPU utilization, for an example. Another way that customers are leveraging auto scaling group is based on number of connections to, say, for example, a web server form that they have as part of that auto scaling group. And the nice thing from a cost savings perspective and how that relates to today's presentation is that you're able to mix, whether you're using savings plans or RIs for your EC2 instances, you can also mix in Spot into those auto scaling groups, since it is going to be a very dynamic workload and scale out and scale back in again. You can leverage Spot there, and that's a fantastic opportunity, which we're going to touch on here in a few minutes with Sabrina further as we get along in the presentation. Hey, Tom, you're muted again, bud.
I'm sorry about that. So we're going to move into a demo here and talk about storage optimization. So here on the screen is the Storage Lens dashboard, and this provides an overview of your storage and specifically where your storage is. So towards the bottom here, I have my top 3 buckets and my example storage class, which represents the majority of my storage. So this is where I want to look for optimization opportunity. So navigating to that bucket, I'm going to find my example storage class. And if you want to change the storage class of an object, you can do so by clicking multiple of your objects at once and editing your storage class. On the next page, you're going to decide what your storage class is, and you can go ahead and say that I'm going to cancel this in the sake of time here. Now, if you want to determine what your access patterns are and when you should be transitioning objects, you can use storage class analysis. So you can find this on the bucket level. So here on the metrics tab, I'm going to use my create an analytics configuration here. And what this will do is it will place a monitor on my bucket and determine which objects should be recommended to move into standard IA instead of standard. So I'm going to apply this rule to all of my objects, and then I can view the results of it here. And so what this is saying is that based on my access patterns, that objects older than 30 days are infrequently accessed and can be transitioned from standard to standard IA, or at least it's recommended. You should always review these. So in order to automate that transition, I'm going to use a lifecycle rule. And back on the bucket level here, you're going to click the management tab and create a lifecycle rule. So I'm just going to name my rule, decide if my scope is going to be for all or some objects. In this case, I'm going to choose all. And here are my lifecycle rules. So going to transition my current versions based off of my storage class analysis. I want this to transition to standard IA in 30 days. And you can also add additional transitions. So in this case for Glacier, I can even transition to Glacier Deep Archive as well. Just acknowledging that Glacier and Glacier Deep Archive do incur a per object cost and is not advised for very small objects. I'm also going to add an expiration rule for my current versions and say that after 365 days, I want my objects to expire. So I can review my summary of my lifecycle rule here. It's going to transition to these lower storage classes as the days pass and then ultimately be deleted. So that's S3. We're going to switch gears here and move over to EC2 and EBS. First, I want to show you how to modernize an instance. Note that an instance can't be running if you try to modernize it. Here I have this T2 Nano that's running, and if I try to change this instance type, it's not a selectable option. Whereas my stopped instance, I do have that option. So it's just a matter of choosing a different instance type. Very straightforward. There just is that interruption that's necessary. And now I have a T3 Nano that's running. So similarly for my EBS volumes, I can find that here on the side, and I have my GP2 volumes here at the bottom that I want to modernize. You can only do one at a time, but the nice part is that you don't need to stop your instances that these volumes are attached to. You can modify them while they're still running. So I'm just going to select my GP3 volume here and go ahead and modify it. And when I refresh this page, you'll see that it's still in use and it's happening behind the scenes. Now there is this available EBS volume, this blue indicator, and this is an unattached EBS volume. And if I wanted to delete it, I can do so by using the actions menu as well. So make sure you do that to delete storage you're not using. Now for Lifecycle Manager, this is where we have our EBS snapshots. So I can go ahead and create that policy here. This needs to apply to certain volumes or instances based off of tags. So I have an application tag that I want to use, and I'll add that. And then I just need to provide a name for my policy. And then on the next page, I'll define what my schedule will look like, whether these snapshots are taken on a daily, monthly, or yearly basis, and however many hours they should be doing this. I can also choose a retention type based on the number of snapshots or the age of the snapshots. So there's some flexibility there as well. I can just go ahead and review this policy and create it. So that's Lifecycle Manager. The last thing I want to show here is the Rightsizing recommendations that are in Compute Optimizer. This is being seen at the payer level, so I have access to all of the accounts and I can see their recommendations. So there's these 4 groups here. We're going to focus on EC2 instances and EBS volumes. The recommendations are account specific, so you'll have to review these separately, but focusing on the one account here, although my instance is optimized in terms of its size, there still could be modernization opportunity. So a T2 to T3 Nano here again. So just make sure that you review all of these recommendations. There's several different graphs you can use for metrics. You can use either an average or maximum statistic to evaluate projected performance during periods of peak utilization. And you can set the CPU architecture to graviton to see the price and performance impact of that as well. For EBS volumes, it's a similar exercise. Again, I have an optimized GP2 volume in terms of sizing, but I could modernize that to a GP3. And then the IO1 and IO2, I've actually provisioned too much IOPS here. And so there's an opportunity to reduce the amount and save some money. So I'm going to use this IO1, and I can actually choose projections for IO2 as well. Again, metrics here that are with using average or maximum statistics that I can view these graphs for. So that concludes the demo. Rob, are there any questions from the audience?
Hey, thanks, Tom. I do have a question here really quickly before we get into the audience question. But when might somebody choose to use, or a customer choose to use Compute Optimizer versus Cost Explorer EC2 resource right-sizing that you were showing before?
Yeah, so Rob, I'll take that one. That's a very common question we hear. And some of the information that you would view within Cost Optimizer is the same information that you would see within the EC2 right-sizing tool as well. The important piece to take away is there are 2 purpose-built tools for different personas within the enterprise. So if you're an application builder that's curious, hey, are my servers right-sized? You would go ahead and enable the EC2 Compute Optimizer within your account. It's not enabled by default. It's something that you have to turn on. And if you want to monitor memory, for example, as well inside of your instances there, you would want to make sure that you have the CloudWatch agent present. Whereas the EC2 right-sizing tool that is available through the AWS billing console as part of the Cost Explorer suite there, that is a tool that is built for the account and billing related person. So imagine being in a large enterprise where you have different roles for different team members that they're able to log in and have access to different things within inside of the console. The Compute Optimizer is for the builder, the architect, the designer, that's actually building on top of AWS, and the EC2 right-sizing portal within Cost Explorer is built for the account and billing related person.
Great, thanks, Clint. Appreciate that. From the audience, we do have one question from the audience from Ray underscore DB222. They're wondering if you have or will be covering anything on migrating GP2 to GP3, more specifically around the best practices and costs.
Yeah, so the best practices around GP2 to GP3 within, I'd say, test it out on dev instances. I will also say that the smaller instance types, 333 gigabytes or lower, it's up to 20%. And once you get above the larger size volumes, the percentage of savings tends to decrease. So for the smaller volume sizes, up to 170 is up to 20% typically. And then if you go from 170 to 333, the savings goes down a little bit. And then once you get above 333 gigabytes in capacity, the savings goes down even less, right? So you would update from a migration perspective. Your mileage may vary, but you would go in and you can change it on the fly. There's a modify volume API that you can call as part of the EC2 suite of API calls that are available there. Or if you want to reclaim capacity, that would be a backup scenario. So making sure that you back up the data, provision the new volume that is smaller in capacity because you can't shrink the volume size there. And then you would do a restore to the smaller volume size. So in reality, in practice, that's what we're seeing customers do there.
Great, thanks, Clint. And back over to you all for the next.
Thanks, Rob. So at this point, I'm going to hand it off to Sabrina for an overview of the AWS pricing models.
Awesome. Thanks, Tom. So AWS does have several different pricing models, and it's important to understand when to use each one in order to optimize costs. So to start, on-demand instances allow you to pay as you go. So this pricing model is the most flexible, and capacity is billed by the hour or second, depending on resources running in the account. On-demand instances are often used when workloads are first provisioned on AWS, as they provide the ability to start and stop billing of those resources as necessary. Moving on to savings plans. So savings plans provide discounts on top of resources that are running steadily. And in order to receive the savings plan discount rates, you will commit to a specific dollar per hour value for a 1 or 3 year time frame. Savings plans are a flexible pricing model that is best used for steady state compute workloads. Reserved instances also provide discounts on top of resources running steadily. However, they're not as flexible as savings plans. So with a reserved instance, you're committing to a specific resource with specific characteristics for a 1 or 3 year time frame. Spot instances, finally, are spot instances allow you to use unused EC2 capacity at a discounted rate of up to 90% off compared to on-demand pricing. So spot instances are best for workloads that can stand to be interrupted when AWS needs to reclaim the capacity of the underlying EC2 instance back. Now that we've gone through an overview of the different pricing models, let's take a closer look, starting with savings plans. So savings plans, as I mentioned, are a discounted rate on top of resources that are running steadily. And with the savings plan, you're committing to a specific dollar per hour value for 1 or 3 years. This commitment has 3 different payment options: all upfront, partial upfront, or no upfront. And there are 2 different types of savings plans for compute workloads. So the first is EC2 instance savings plans, which are going to offer you the greatest percent of discount with savings up to 72% compared to on-demand. EC2 instance savings plans are flexible across instance size, operating system, and tenancy. This means that if any of those variables were to change, for example, if you were running an M5 extra large and you move to an M5 4 extra large, since that's a change in instance size, the savings plan discount rate will still be applied. And the compute savings plan, on the other hand, will not offer as high of a percentage of discount. However, it will provide the greatest amount of flexibility. So compute savings plan discounts are flexible across instance family, AWS region, operating system, tenancy, and along with covering Amazon EC2, the compute savings plan will also cover AWS services, AWS Lambda, and AWS Fargate. There is a third type of savings plan, Amazon's SageMaker. But before we jump into that, Clint, question for you. Do you have any examples where customers of yours leverage savings plans to cost optimize?
I do, Sabrina. Recently, I worked with a customer here in enterprise support that was brand new to enterprise support as of June 1st of this year. And upon beginning to work with them, their daily EC2 costs were around $2,800 per day, which was and after doing some rightsizing, taking a look at trusted advisor reports and working with them to right-size and optimize their EKS environment. They had worker nodes that had not been properly cleaned up, and they also had some other instances that were sitting out there idle. We were able to decrease their daily EC2 spend to down to around $700-800 per day. So if any cost savings endeavor that a customer is going on, it is definitely an adventure, and it is a journey. It is a constant ongoing effort, and it's not just a one day, set it and forget it. Oh, I'm cost optimized type thing. It's something that you need to keep an eye on and make sure that you're keeping track of. So once we got that customer baseline where their EC2 spend was, or like I said, around $700-800 a day, they felt that there was still room for improvement that they could do there. So they went ahead and they actually purchased a compute savings plan for around $25 per hour commit, which, as you mentioned before, it's based on a dollar amount commit per hour. So this customer went ahead, they went in for a savings plan at $25 an hour. They were able to benefit from those compute savings plans there. And it was a good story, and that was definitely something that we're constantly trying to work on with them to refine.
Awesome. Thank you. So moving on, I mentioned there is a third savings plan, which is for Amazon SageMaker. So Amazon SageMaker savings plans were announced in April of 2021, and they allow savings of up to 64% compared to on-demand. SageMaker savings plans are structured in the same way as the EC2 and the compute savings plans were, in terms of you'll choose a term commitment, term length, and then payment option. SageMaker savings plans are flexible across instance family, instance size, and AWS region. And SageMaker savings plans apply to several SageMaker machine learning instances, including SageMaker Studio Notebook, on-demand notebooks, processing, data wrangler, training, real-time inference, and batch transform. So now that we've covered savings plans, let's take a look at reserved instances. So reserve instances, as I mentioned, are a pricing model in which a discounted rate is applied on top of resources that are being used steadily. And similar to a savings plan with a reserved instance or an RI, you're committing to either a 1 or a 3-year term and have the 3 different payment options: all upfront, partial upfront, or no upfront. And in order for the RI discount to be applied to the specific AWS resources, the attributes chosen upon commitment must match what's running in the account. And those RI attributes include instance type, region, platform, and availability zone. Reserved instance discounts are available for the AWS services, Amazon EC2, Amazon RDS, Amazon Redshift, Amazon Elasticache, and Amazon OpenSearch Service.
So Sabrina, I have a question for you there.
Yeah.
When do customers typically choose RI versus savings plan, and which one should they be taking a look at then?
Yeah, that's a great question. So I would say if you are looking to cost optimize your Amazon EC2 instances, it is the best practice that you would look to optimize via a savings plan, because savings plans are going to offer the same amount of discount as a reserved instance for EC2, but the savings plan is going to provide that same discount just with greater flexibility. So I would definitely say for optimization of EC2 to look at reserved instances. Look at savings plans. Now, if you did have those other services mentioned on the screen here, you're looking at RDS, Redshift, those services where we don't have savings plans available, that's when I would say let's take a look and potentially leverage a reserved instance. But for EC2, best practice would be to look at the savings plans. Great question. So with that, we can move on to spot instances. So with Amazon EC2 Spot, EC2 Spot instances allow you to take advantage of the unused EC2 instance capacity at discounts of up to 90% compared to on-demand pricing. And Spot instances are best used for stateless, fault-tolerant, and flexible workloads that can be interrupted when AWS needs to reclaim capacity back. And then when that happens, when AWS does need to reclaim the capacity back, you would be notified via a 2-minute warning. And during that time, you have the choice to either hibernate, stop, or terminate the Spot instance. Spot instances can be integrated with several AWS services, such as AWS Autoscaling, Amazon EMR, Amazon ECS, AWS CloudFormation, Amazon Data Pipeline, and AWS Batch. And common Spot workloads include big data, testing and development, containerized environments, and high-performance computing. So with that, we do have a demonstration to see how these different offerings would look in the console. While we're pulling that up, are there any questions from the viewers? Rob?
Hey, Sabrina, thanks. Yes, we do
Yeah.
have one question that came in from Ray_DB222. Welcome back, Ray. If I opt into the savings plans, can I still use RIs?
Yeah, so you can use RIs and savings plans together, and customers do that. The way that the RI and savings plans would get applied is where the greatest amount of savings is able to be achieved. That would get applied first, and then any leftover on-demand cost that could be covered by the savings plan or the RI, whichever one is left over, would then get applied after. So it's based on where the greatest amount of cost savings is able to be seen.
Thanks, good. Appreciate that. That's all the questions for right now. Thanks.
Awesome, thanks. So with that, we'll run through a demo of how those would look in the console. So just going to go to the top search bar and type in savings plans. And then select AWS Cost Explorer at the top. And with this, it's going to take you to the AWS Cost Management page. We're just going to go into the left-hand side here and click on Savings Plans Overview. Now, this is going to show any active savings plans in the account via the summary, and then any potential savings opportunities. So just a nice overview page here. Moving on, we'll take a look at savings plans inventory. And on this page, you'll see the savings plans in the account. So you'll see the type of savings plan, the commitment amount, and the start and end date. So moving on here to recommendations. So this page is where you would go to see what AWS would recommend for a savings plan commitment. You can see the 3 different types of savings plan options I mentioned. And then scrolling down, you'll see the savings plan term, so 1 or 3 years, payment option, and then look back period. And this is all a dynamic page. So you can see here, if I change this to 3 years, the recommendations, the values in the center of the screen will change. Similarly, if I change it to no upfront, the values for the commitment and savings would change. So looking here, how to kind of break down this piece. Right now, for this 3-year term, the system's recommending a $0.063 per hour commitment based on the usage. And with that, it's going to cover what's currently being spent monthly on demand of about $74. And instead, it's going to provide a savings plan commitment recommendation of $0.063 per hour, saving approximately 38% compared to on demand. So that's how to read this, is the percent savings based on the recommendation compared to on demand. Definitely recommend taking a look at this recommendation page and seeing what recommendations you have. And then that orange button at the bottom, the Add Savings Plan to Cart, just feel free to click there if you wanted to go ahead and purchase the recommended savings plan commitment. You would just add that to your cart and then view the cart here on the left-hand side. At this point, you would select the commitment amount by clicking on the checkbox on the left-hand side. And then once that's selected, you can see the summary and you would just submit the order. So there is one other option of how to purchase, and that's clicking on the Purchase Savings Plan section on the left-hand side. So the main difference here, you'll still select the savings plan type, and then enter your term length and then payment option. The main difference is that you can type in an hourly commitment. So if you wanted to, say, do $0.05 per hour as a commitment, a bit more conservative than was recommended, you have the freedom to make that commitment custom. You would just add that to your cart. So that's savings plans. Now, if we want to go back to the AWS cost management page, I'm going to scroll down here to the reservations. So looking at reserved instances, there's a similar model as with the savings plans in that there's the overview section and the recommendation section. So we'll click into overview to start. Same thing, you'll see the summary page, any savings opportunities for reserved instances. Then going into the recommendations section, this is where you'll see, similarly, you'll select the term length and the payment option. One thing to note here is that there is a drop down for the specific service, because reserved instances, there are different services, right, that we can look at. For example's sake, we'll take a look at RDS. So we'll just use the drop down there. Still, this is dynamic, so you can select the term length and payment option, and you'll see the values change. Based on the recommendations here, we're seeing 4 purchase recommendations. And we can scroll down to see which RDS instances are recommended to commit to an ROI for. You'll see the monthly savings, upfront costs, and reoccurring monthly cost. If you wanted to move forward in purchasing a reserved instance, you would just click into the different reservation purchase console. So the link here is where you would go to click there. And then last but not least, taking a look at spot instances. So you'll just go into the search bar, we'll type in spot instances, and we'll click on EC2. So this will take us to the EC2 dashboard. And then on this page, once it loads here, we'll go on the left-hand side and click on spot requests. So clicking into spot requests here. At this point, you could go onto the request spot instances section in the upper right, click on that button. And then at this point, you would insert the specific information you wanted to configure those instances. So just scrolling down here, if you wanted to launch the spot instances from a template, all the specific preferences for the instances, you would enter on this page. And then if we scroll all the way down to the bottom here, you will see that there is a Your Fleet Requests at a Glance section. And this is going to give an overview of the target capacity, instance configuration, and you'll see the estimated hourly price and the % savings compared to on-demand. So if that looks right to you, you would just click the orange launch button, and that's how you would start launching your spot instance. So with that, want to transition back to the deck here, just for some final closing words here. Perfect. So just as a final recap, we have compiled some checklist action items, best practices to take in order to optimize your storage and compute costs based on the topics covered in this presentation. So I won't read through all of these, but feel free to take a look, and recommended to take some action here in order to optimize that storage and compute cost. So with that, just want to thank you so much for the time. We hope you found this to be helpful. If you do have any additional questions or would like to review any of these topics in greater depth, feel free to reach out to the email on the screen. And don't forget to tune in to our next session on Monday, October 18th, where we'll cover monitoring your environment health. So thanks again.
Thanks, Sabrina, Tom, and Clint. Appreciate it. Everyone, today we looked at AWS cost savings for compute and storage. If there are any questions that were not answered today, you can post your questions on forums.aws.amazon.com. And if you have any suggestions or feedback for the show, email us at awssupportsyou@amazon.com. We want to hear from you, so let us know what you'd like to see. Thanks for joining us at AWS Supports You.